And I will share my screen and we will get started. Thanks for being on time, everybody.
Robin, I don't have that board.
Use your spiral and that will have to do, okay? So
Yes.
just so you know, in Google Classroom, you always have this assignment under math. What does she need? Okay. Today is Tuesday, got to double check. And we are looking at lesson 6.7. All right. Our learning target today is to compare areas and perimeters. We're going to recognize that rectangles with the same perimeter can actually have different areas, and rectangles with the same area can have different perimeters. So this will just help us with solving more real world math problems that involve area and perimeter. You're going to be drawing. That's why I wanted you to get your boards. I want, if you don't have the board for some reason, you can always use your math spiral. But if you're in person, I have extra boards. Okay, so we're going to draw all the possible rectangles with a given perimeter whose side lengths are whole numbers. And then we will then look at their areas and compare them. And then we'll do the same thing where we're given the area and we will compare their perimeters. So before we do that, yesterday we heard a song about area and perimeter. And I'm probably going to keep playing it for the week so you get in your head the difference between area and perimeter. This is the one from last year. Remember it? I got this stuck in my head last year for sure. I finally found it. Outside. Measure around the window for a tour out of the length of all sides. It's the outside. right. So hopefully that just reminded you of what we're going to be talking about today and the difference between the two, because sometimes I think that's what's tricky. I know on your exit ticket, a lot of you swap the two terms and you said areas, the distance around, and perimeters, the inside. So I think the more we hear the song and the more we practice, we'll be able to decipher the two. So another thing we needed to talk about yesterday and didn't quite get to was finding the unknown side length in a rectangle when given the area or perimeter. So I'm going to show you, but actually I think a little discovery learning might be good here. You see how much you understand about multiplication and area and finding missing factors. So let's look at number 14 together on page 323. So you can put your boards to the side. You don't need them yet. So Robert, we're going to find our math workbook. Page 323. Some of you don't seem to know what I'm talking about, but our math workbook is where we're starting, and we will use the boards. So on page 323, you will see a page that says find unknown side lengths. On number 14, you'll see that it gives us the area and one side length, which is 8 centimeters, but not the width. So I want you to think about what you know and how you might find this width. If I know area equals length times width, and I have 72 as the area, which equals 8 times W. W is standing for the width or the unknown. You can use it as a variable. How can I find out what that is? I just want you to think about that for a minute. Because you can do this. You've done problems like this. I'm going to give you a minute to think about it. Don't make me figure it out for you. Even if what you know, have confidence that you can figure this out. If you haven't written area equals length times width and 72 equals 8 times W, will you write that now? Because that will get you thinking. Can you write that in your math workbook for me? I think that's going to get you thinking, and I think that's going to, it's right over here. Just like I did, it doesn't matter. This is to be thinking. So hopefully some hands will go up. And you can tell me, I think I know, Mrs. Aubin, how we can find out what W is. I think I know what that width is. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. We're getting more and more hands. Let's see my friends at home. I'm challenging you to be independent thinkers. Mrs. Grayway and I are good friends. We were neighbors. She's the 5th grade math teacher. And she would love it if by the time you get to 5th grade, you can think independently. At least try to come up with an idea. Henry, will you unmute? What are you thinking, my dear?
9.
What, can you explain your thinking? Right, but can you explain it?
Because 8 is one more than 7. I usually use my trick on how to use the 9's trick. And if I see a number that has the number 2 and 8, I would plus those together and it's 10. So divide the 2 and you get 1. So
okay, that doesn't make sense to me. I'm not, because 1 is not the answer, Henry. You said the answer is 9. Where did you get your answer, my dear?
I just knew it straight off my head.
Okay. Let's see. So one of the things in math, Henry, that you get graded on, Henry, is explaining mathematical thinking, right? So I want you to try with your words. Think of it as an exit ticket with words. How would you explain that W equals 9. Look at the equation I wrote. How can you figure that out?
8 divided by 72.
You're very close, but you would not be able to get many 72s in 8. What number comes first when you're dividing? The bigger or smaller number?
The bigger one.
So could you say 72 divided by 8?
Yes.
Okay, so that's one way, Henry, that it would work, right? That's one way. You could use the inverse operation. If you want to figure out the multiplication fact, you can always use the inverse. 72 divided by 8 equals 9. So 8 times 9 must equal 72. Another explanation, Ellie.
I know that 8 times 5 is 40. And if you add, you add 4 more to that, you get
Okay, so she used kind of distributive property. She knew 8 times 5 is 40, right? And she wants to get up to 72. So she said, if I add 4 more 8, I would get 72. So you're really trying to figure out what times 8 equals 72. And to do that, like Henry said, you would divide, you use the inverse operation. So go ahead and write that. You can write 72 divided by 8 equals 9. W equals 9. Excellent. So let's do this. Before I confuse anyone, I want you to circle certain numbers. Let's circle number 17, number 19, and number 20. Just circle those 3. Now, these are very similar problems to the one we just did. They're giving us the area and either giving us the width or the length, and we have to figure out the other side. So, on number 17, let's look at number 17. We'll do this one together, then you guys will do 19 and 20 on your own. If the area is 56 and it's 7 centimeters long, how can I find the width? Marin, what am I going to do?
56 divided by
56 divided by 7 equals the width. Or you could look at it like this. 56 is the area equals length times width, right? So what is W? What times 7 equals 56? Okay, so go ahead and solve it and write it down. How many 7s are in 56? And that'll give you your unknown side. Oh, sorry. Does that say no? Right. Don't forget your unit is centimeters. I forgot the unit on the last one. We're looking at centimeters. cm. cm. You'll see it up there, right? Centimeters. All right, let's see how we did. Next, Beesburg. What are you thinking? What does W equal? How do you know? By 7. So there's, if we counted by 7, 8 times, you get 56? Sure. Nicely done. Use that inverse operation. What times 7 equals 56? Okay, do numbers 19 and 20. Make sure you circle 19 and 20 because the other problems are different types of problems that we haven't talked about yet. So I just want you to practice with area. When given the area, how do you find an unknown side? And it looks like you guys are telling me divide or use multiplication, a missing factor to figure it out. So go ahead and do those 19 and 20. You're working independently. forget your label. I know, I need to write it. Don't forget your label. Ooh, looking good. How about you, Mrs. Harrison? Well, I have a couple I had to remind you to together. But otherwise, looking good. Okay. Put your label on it. Right. So, yeah, not that one. That one's on this one. You know, she was 7 and 1, right? All right, how do we do? Number 19, let me pull out of my handy dandy can. Sawyer's not here. Charlie Carr, what'd you get? So you can't divide 63 into 7, it's not big enough. What do you gotta put first? What's gonna be your dividend? The dividend's the big number, remember? Dividend. Then the divisor's smaller, and then we have the quotient, which is even smaller. So can you switch those numbers around? Okay, what would you get? I heard 63 divided by 7 equals 9. You should have gotten 9 centimeters. Okay, did you guys agree at home then? Do you agree? All right, number 20. Charlie D's not here. Ryder's not in my group. But you can't do it. Ethan's not here. Okay, Sawyer Jackson. Lucas, what'd you get for number 20? 4 centimeters. Can you explain how you got that? Well, you can't divide. I don't know why you guys are putting the small number first with division. You can't do it. The dividend is the big number first. What is the big number? Divide, no, we know the what. What's the what? 20 divided by what? What's the number we know? 7 equals the width. What times 7 is 28? You guys know? 4 centimeters. All right, so that was an easy way to figure out the length side. Now it gets trickier. That was a one-step problem, right? When we have to find the side length and we're given the perimeter, it is not a one-step problem. Okay, thank you. Okay, bye-bye. So let's look at, now I'm gonna erase all of this because I don't want to confuse you. Now we're gonna look at what happens when we are given the perimeter. If the perimeter is 38, and Max, if the perimeter is 38, and we know that the perimeter equals the length plus the width plus the length plus the width, how are we gonna figure out that unknown size? Any ideas? Sunny? If I do 38 minus 12, what is it gonna tell me? You're close, but what do we know? What do you mean? Okay. What do we know? If we know this is 12, what do we know about this side? It's also 12. Go ahead and write that in your math workbook. So in your math workbook, you're on page 323. Go ahead and write that. Why don't you come over here, sweetheart, so you're not talking to me. Okay, come on. So if we know we have 38 equals 12 plus W plus 12 plus W. Right about you for this info, I'm going to tell you that. They just called when you were out. Of course. So think about this. 12 plus, he's probably still here. Sorry. Oh, yeah. If we have 12 here, W plus W. Any ideas now what we might do? Lila Merritt.
I think that we might divide 12.
Well, we're not dividing. That was before. Now remember when we find the perimeter, we're adding. Yes. Okay, just stop there. First, we have to do 12 plus 12. What's 12 plus 12? If we know 12 plus 12 is 24, we need to subtract that. You need to do this with me from the perimeter. Go ahead and do that. And then tell me what you get. Cooper, do you have your answer? Can you do it for me? If we know these two sides are 12 and that equals 24, we still want to find out what these two sides are. So we can find out the width. Lyric, what did you get when you subtracted 24 from 38? Well, do it. Tell me right now. What's 8 minus 4? You got this, girl. Yes, you can. If I had 8 fingers, I can take 4 away. And so can you. It equals 4. What is 3 minus 2? 1. So now we have 14, but it's split between 2 of these W's. Are these the same number? Yes, because opposite sides are equal. That's why we knew 12 equals 12, right? So if we know we have to split that 14 equally between those 2 sides. Josh Carter, how am I going to do that?
One way you could do it is
So this is 12 and this is 12. That's 24. I have 38 centimeters around the whole thing. I have 14 left to split between 2 sides. And they have to be the same. How can I find out what that's going to split into equally? You're right, but how do you know? How do you know it's 7? You're right. I'm not sure you did in your head. I'm going to take over for you. If I know 7 plus 7 equals 14, right? It's a double fact, then this would work. Or I could have, what?
divided by
That's it. Divided, I could have said 14 divided by 2 because I have to split it equally between those 2. Is that a one-step problem? That was 3. Max is paying attention. We first had to double the length, subtract it from the perimeter, and then divide it by 2. Oh my. All right, now we can kind of think of it as a little formula, maybe. You think we could? Let's write down the 3 steps that we just did to figure that out. First, double the side length that you know. Second, subtract from perimeter. From perimeter. And third, divide by 2. All right, let's see if it works. Are we looking at number 16? Let's look at number 16. Is this 24? 24. Okay. So the perimeter is 64. We're all looking at number 16 now. Here we are, 16. We said to double the side length. The side length is 24. Let's double it. Ready? 24 plus 24. Everybody write it. Oh, you already know it. Oh my gosh, you're so smart. We know it's 48. Excellent. So we can move on quicker this time. So we did that. Now it says subtract from the perimeter, which is 64. Go ahead and stack it. This is good practice since you didn't have our review. 64 minus 48. Subtract it from the perimeter. You're writing this now. You're not sitting here just looking. You're writing those problems. I guarantee you, if you are not writing this, this is going to be very foreign to you. That's that word. It's going to be foreign if you don't practice this and try and follow along. All right, Mervin, walk me through 64 minus 48. Can I do 4 minus 8? No way. So, Lyric, if I only have 4 fingers, can I put 8 down? No. So now what do I do, Marin?
Make it a 14. And then 14 minus 8 is 6.
Excellent.
And then 5 minus 4 is 1.
All right, so I did that. I subtracted from the perimeter. What's left, Paxton? What's the third thing? Divide. Divide it by 2. 16 divided by 2. Go. How many 2s are in 16? Count on your fingers. See what you gotta do.
8.
Oh, is that as hard, Sonny, the second time? Wasn't that easier now that we kind of see how we did it? Yeah, when we had to figure it out, it was kind of tricky, but we got 8. So the length side would be 8. I am going to do one more with you because these are tricky, and then I'm going to give you one to do on your own. All right, I'm going to erase all of that. All right, let's look at number 18. Follow the 3 steps. Okay, it says double the side length. Elena, what do I do? How do I double the side length? What's the side length? So I double it. How do I double something? I could, 30 times 2. Or you could add it. Let's just be easy and double it. If you want to do 2 times 30, you can get the same answer. I just want to try to be more simple. All right, Henrik, we're doubling 30. What did you get? 60. All right, second step, Astria, what do we do next?
you subtract 60 and 72.
Subtract 60 from 72. Nice and easy. Ready, Lucas? Let me see you do it. Put that away. You don't need it. Pencils are moving. You are subtracting 60 from 72. Look at those pencils moving. So Renee, what is this 60 from 72? What's the difference? I have 2 fingers and I don't take any away. I still have, how many, Renee? 2. 7 minus 6. I have 7. I take 6 away. What do I get? Renee, what do I get if I have 7 fingers and I take 6 away? 1. So you should have gotten the microphone answer. 12. Madison, what's the third step? We did the first, we did the second.
Divided by 2. Divided by 2.
So our width is 6 centimeters. All right, if you follow those 3 steps, I think you'll be fine doing number 21 on your own. Go for it. All right, everybody work on 21. Think that guys, double, subtract, divide. Double, subtract, divide. Let's make it super simple. Okie dokie. All right then. Mr. Bowers, can you unmute? How would I double 7?
Yeah.
That's my side length and we're supposed to double it. How can I double it?
I think you do like 7. I think you do 7
Then I want 2 sevens. I want 2 sevens. How do I get 2 sevens?
Oh, don't you do like 7 plus 7?
Yep, and what would that equal?
So, 14.
Okay, now I'm supposed to subtract that from the perimeter, which is 28. What would I get then? 8 minus 4 and 2 minus 1.
You can't do that.
Sure I can. If I have 8 fingers, I could take 4 of those away. Put up your 8 fingers. Take 4 away, everybody. Put up 8 fingers. I think we're getting confused. If the number on top is bigger than the number below it, you can do it. I think I've done too many here. What did you get, Ben, when you took 4 from 8?
4.
Awesome.
4
All right, minus 1. Put 2 fingers up. Take 1 away.
1.
Awesome. Now divide it by 2 because we need to split it in half. Count by 2s till you get to 14.
Sorry, say that again.
Count by 2s till you get to 14.
7.
Excellent. That's your answer. The only problem I have with this is it's not a square. Shouldn't it be a square?
No.
Yes, if it's both 7 centimeters this way, 7 centimeters this way. That's a little bit of a mistake on the mathematicians who created it. All right, that was a lot. All right, shake out your hands and show me fist to 5. How do you feel about finding a side length when you only get the perimeter? What we just did, fist to 5. That was a lot. Where you have to use 3 steps. Okay, shake out your hands. What about when they give you the area and all you have to do is divide or think of the missing factor in your multiplication? How do you feel about that? Is that a little easier, finding the unknown side length? Yeah. This is something that I would hope, Mrs. Harrison, I don't know, did you teach 4th grade math?
I did.
Did they hopefully go over this again?
Yes, we did a lot of areas.
Okay, so this is kind of, to me, like a preview into 4th grade, because that's heavy. That's heavy stuff. But I think you guys rocked it. So that was from yesterday, and I'm not going to do that because I haven't even got to today. Wow. All right, here we go. So we're going to look at page 325, but I don't even know that I'm going to worry too much about this page, writing in it. You're mostly going to be drawing on your boards because I think that's what you need right now. So get your board. You need a board? The board's at the back table. You can grab one. Get your boards with the dots, okay? It looks like this. And I think that is going to help your brains right now. The first thing we are going to do is we are going to look at rectangles that have the same perimeter. So here's what we'll do. We're going to use our centimeter dot grid because between each dot is about a centimeter. And we are going to draw all the possible rectangles that have a perimeter of 12. So think about that. The perimeter has to be 12. So let's try it. Are you guys ready? We're going to just try it. The nice thing about the dry erase board is if it doesn't work, we can erase it. Yes, Vernon. The perimeter is the distance around. So I'll help you guys. Let's do it together. Get your board. So I could draw a rectangle just like this. And then I could say, does it have a perimeter that equals 12 centimeters? Let's count. 1, 2, 3, 4, 5, 6. The perimeter equals 6. Can I use that one? No, that one's not going to work. So you can play with it. So you can find a rectangle that has a perimeter of 12. So I'm going to play around and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did that work? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perimeter equals 10. Is that it? No. I gotta keep trying. That's what I want you to do on your board right now. I'm not gonna give it to you. I want you to discover it. But well, and think about what I'm doing. I'm just drawing rectangles, hoping to get a perimeter of 12 by counting the sides, making those tick marks. See how, if you've already got one, see if you can find more. So count that again. I don't think that equals 12. Throw it away. Let me give you a little hint. Area equal, sorry. Why am I thinking that? No, never mind. This is what I want to write. This is what I'm writing. Here, perimeter equals length plus width plus length plus width. So think about what numbers your side length might be. You can think like that, or you can just roll and discover. But that's how we find perimeter. Length plus width plus length plus width. You found two? How many of you already found one? Oh, you guys are so good. Awesome. Awesome. Anybody at home find one yet? Gavin's here. Gavin, yay. Gavin, have you found a rectangle that equals 12 centimeters for its perimeter? Can you unmute? I'm guessing you're not there yet. Astria, you're bursting. Do you want to share?
Yes.
Okay, go ahead.
Okay, so I got one. I got one that was 12 units. 12
Oh,
centimeters, I guess.
Yep.
12 centimeters. So what I did is for the top, I made it so it would go 5 dots, and then for the bottom, I made it go 2 dots, and then wait, no, I made it go to 1 dot.
Hey,
Then
can I ask you to count by centimeters? Like between each dot is 1 centimeter length? Like think about the length and the width. What was the length and width of your rectangle? What by what? Was it 4 by 2 possibly?
yeah, 4 by 2.
That's what I thought. So let's draw. And Astria, make sure I'm doing this right. Okay, this is what I think Astria did. 1, 2, 3, 4. Down 1, 2. 1, 2, 3, 4. Up 1, 2. So you have 4 here. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. 1, 2. And if you add that all up, 4 plus 2 is 6. 4 plus 2 is 6. 6 plus 6 equals 12. Anybody else get a 4 by 2? Yep, Gabe got that too, Astria.
So can I point out that a lot of them had that just the turn, and that's perfectly fine. That's like community of property, right? So yours might look exactly like that, but on its side.
So what Mrs. Harrison wanted to point out is that some of you are using community of property, which is celebrated. So you would have done something, the same one, of course, it's distorted on mine.
I just wanted to make sure they knew that. that was
1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Oops, I already did that. 1, 2. So you might have the same thing as Astria, but just flip, right? Does anyone have a different one than the 2 by 4 or 4 by 2? Marin.
I got a 3 by 3.
Well, let's see. What kind of shape is that?
Square.
A square. Wow, how smart is that? So give a thumbs up if you got a 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And it would look better if my board wasn't destroyed. 3, more like this. 3. How do you know if the perimeter is 12, Miss Marin?
I did 4 times 3, and I know that's
4 times 3 equals 12, or you could have done 3 plus 3 plus 3. I'm so excited you guys are moving right into that multiplication.
I
Good
also
for you.
did another one.
You got, did anyone else? Let's see if anyone else got a different one.
There's another one out there.
Another one. Sergey, what is yours?
I might like
As long as it's not a 4 by 2 or 3 by 3. Oh, Gabe, is that what you got too?
I got it too.
Yeah, we got
All right.
several. Smarty pants. Both Cedar.
So 1, and it can go either way. 2, 3, 4, 5, 5, 1. So if you had 1 here, 1 here, 5 and 5, 5 plus 5 is 10, 11, 12. All right, here's what I want you to think about. You have to write this on your board and hold it up. If I were to look at the area of this rectangle and the area of this rectangle and the area of this rectangle, are they all going to be the same since they have the same perimeter? Right? Yes or no, and hold it up. So all of these rectangles have the same perimeter. Does that mean their area is going to be the same? If you think yes, write yes. If you think no, write no.
Tell those friends at home to show me.
Show Mrs. Harrison if you are remote learning, hold up your board to say yes or no. If a rectangle has the same perimeter as another rectangle, does it mean it has the same area? Henrik, I want to see your thinking. Yes or no? I'm curious about your thinking, Haley. And Max, I'd love to see your thinking. August, I'd like to see your thinking. A lot of yeses, some no's. Very interesting. Okay. Lots of yeses. Interesting. Okay. What you see at home, Mrs. Harrison?
I have 3 no's and 2 yeses.
Okay, about half and half. So how are we going to find out if we're right, Robert? What do I have to do to find out if their areas are the same or not?
count them all.
Let's count them. Okay, let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8. A 2 by 4, 2 times 4, has 8 square centimeters. All right, let's look at the 1 by 5. Count it. 1, 2, 3, 4, 5. A 1 by 5 has an area of 5 square centimeters. Hence 1 times 5 is 5. Let's look at the 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. A 3 by 3 has an area of 9 square centimeters. So what should you have written on your board? No. No. Just because a rectangle has the same perimeter, that does not mean that it has the same area. Pretty interesting. I think if I were you, I would have said yes if I didn't see it. Okay, erase your board. Erase your board. Ready to roll?
Ready to roll.
Now we're gonna try the opposite. Before we even start, I just want to see what you think. If we have rectangles that have the same area, will they have the same perimeter? Stand up if you think yes. Let me repeat it. If I give you, because we're going to investigate this next. If I say that I have 3 rectangles, Serene, and they all have the same area, okay? Will they all have the same perimeter? Stand up if you think yes. Is anybody at home standing up? I don't see. Oh, Haley is saying yes. Gavin, I can't tell. You're moving forward. Jensen's staying seated. Gavin is getting up. Haley is sitting. Reese is staying sitting. Okay. Stand up if you think no, that they can have the same area with a different perimeter. Okay, it looks like the majority, Jensen is standing, Haley is standing for no. Reese is standing for no. All right, let's investigate. Clear your boards. Now what we're gonna do, we are gonna draw all possible rectangles with an area of 12 square centimeters. Watch how I'm gonna do this. I think you're gonna find it a little easier. I might draw something like this. I'm just gonna experiment. I think that's gonna be 12. 1, 2, 3, 4, 5, 6, 7, 8. Not quite, but look what I can do. I know that's 8. 9. I could say 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. And then I can keep adding on. You want to find as many rectangles as you can that have an area of 12. That means that there's 12 squares inside of it. If I did something like this, and it only had 4, that is not what I want. I want the area equal 12 square centimeters. Go for it. See how many you can come up with. Use your dots. Turn your board on. Use your dots. Oh, thank you for clarifying. I heard Mrs. Harrison say, don't forget, it has to be a rectangle. We are now looking at different figures that are concave.
just rectangles. Good question from Elena. Since a square is a rectangle, can we draw a square? Yes. I encourage you to draw a square. All right, keep working and listening and coming continuously. You can do that. Gabe has one. See if you have this one as well. Gabe, give me one of your examples. I think he ended up with 3. Some of you get 3? One of them has 3. Which did you get, Gabe? So if I go like this, 2 by. I like his language, a 2 by 6. You sound like a builder. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Area equals 12 square centimeters. Good job, Gabe. A different one. Lucas. I saw a lot of 1 by 12. Okay. Well, we're going to try to go straight because rectangles have right angles, right? So 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. Uh-oh. Mine's going to not be able to go all the way up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to add that other one and make it 12. So a 1 by 12 area equals 12 square units. Is there another one? Other ideas? Josh and Cooper, did you only get these 2? Oh, I'd love to see your hands up. Cooper, what did you get? A 3 by 4. Okay, I'm going to erase this one. We'll go 1, 2, 3. 1, 2, 3.
4. Did anybody get this one? And maybe it's just turned the other direction, going horizontally? Yes, Paxton did. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Area equals 12 square centimeters. All right. Here's what I want you to think about. If a rectangle has the 3 rectangles, and they have the same area, Larry, does not mean they have the same perimeter. Write your answer on your board and hold it up. If you are at home, write yes or no, and you don't have to erase everything. Write it somewhere and hold it up. Do you think if 3 rectangles have the same area, do they have the same perimeter? Yes or no? Do they have to have the same perimeter if they have the same area? I see more of a consensus now than I did before. All right, I see Reese, Jensen, I see your board, but I don't know if I see the word. Okay, we don't see your yes or no, Jensen. We'd love to see it. Gavin and Haley, love to see your thinking. Okay, wow. All right, I see you, Jensen. I see you, Haley. Gavin, still waiting on you. Astrid, I see you. Henry, love to see what you're thinking. All right, I am going to ask, who did I want to ask? Reese. Reese, can you unmute and tell me your thinking about this?
I said no.
He said no. Go ahead and put your boards down. Why do you think that's not the case? Haley and August, listen to Reese. She's got some great thinking to share with us. Marin and Bird, listen. She agrees with you guys. Every single person said no. Why do you think that's not the case? Why do you think that just because rectangles have the same area, that doesn't mean they have the same perimeter?
Because they're not all the same number on each side, but they equal the same number.
Oh, the area equals the same, but the perimeter's not. Watch, let's do it. You guys ready? Let's count the sides. So this would be 12 plus another 12 if I'm finding perimeter. What's 12 plus 12? 24 plus the 1, 25, and another 1 would make 26 centimeters for the perimeter. Let's try this and see if it's 26. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perimeter equals 14. Is that the same as 26? All right, one more. 1, 2, count with me. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, the 16. So look at that. Perimeter of 16, perimeter of 14, perimeter of 26. However, all of them have an area of 12. All right, the learning target today was not about all that fun stuff we started in the beginning. That was from yesterday, but we already told how we felt about that. What I want you to think about is what we just did on the board. When we compared the areas and perimeters of rectangles, like what the perimeter would be like if you had the same area, and what the perimeter, the area, if you got the area, no, if you had the same perimeter, what the areas would be like, if they would be the same or different. What we just did on the board. Let's do a quick thermometer on that. How, I feel like you guys really got it. How did you feel about it today? The second part of math on the boards. Haley's giving me a thumbs up. Jensen, how did you feel about it? Were you feeling successful? Yeah, a little bit. Gavin, thumbs up. Reese, I could tell you got it the way you explained your thinking. Well done. Astria, you were really participating nicely. Henry, you did a great job as well. Thank you guys. Is there anyone with a thumbs down? I mean, don't say it. I just want to look. So I can give you some extra. Okay. You feel like you could use some more support with it. Okay, thank you. All right, very cool. All right, kiddos, you may clean your boards. Kiddos, we will see you tomorrow. Don't forget your Think Central, my remote learners, and I will see you manana. Have a wonderful
Bye.
evening.
Bye.